Hello everybody. So I wanted to start off today with making sure you are all set to go here for a good learning experience and not a waste of time, right? So prior to watching this video, you should have completed the entire extra credit all on your own. And if you need to look something up, that's no problem, but then circle that problem because that was something that wasn't completely sound yet, but it will remind you to go back and review that. And then after you are done doing the whole thing, you should have already corrected it. And again, circling maybe even in a different, or correcting it so you know which ones are wrong. And then for sure, watching those parts of the video, that the questions that you got wrong, to see how to do it, but then to go back, reprint, and try those specific problems again. So that's where you should be at right now. So you shouldn't be starting to watch the video unless you've attempted and completed the entire extra credit at this point. And also, shoot, lost my train of thought. It's okay, it'll come back. But also be in a position of learning, right? I'm preaching about this lately. Don't be laying down on your bed or, sitting on a couch with a phone like you're watching a movie. Okay, so be sitting at a table, have your pencil in hand with the correction that you've already done right in front of you so you can take notes, you can rewind, you can really figure out those problems that you're still having trouble with, okay? So before we start, I have a blank piece of paper here, and I want you to also take a blank piece of paper and try to think if you can, of all the different ways that we've talked about on factoring. See how many of them you can remember. Now keep in mind, I am going to keep that thing on the board with all the whole list there, so it is there, but having it there and knowing how to use it are two different things. So remember, we have all these different factoring methods. What was the very first one that was on there? GCF. Again, that was looking for greatest common factor in whatever I give you to see if you could take either a number or variable or both out to simplify what's inside the parenthesis. Doesn't mean you're done after you do that. It means it makes the problem inside the parentheses simpler to look at and see if you can even do more with it. So how many terms can you use GCF for? Any number of terms. Right? You could use GCF on 2, you could use GCF on 4, you could use GCF on 3. It doesn't matter. You can always see if there's a GCF. Number 2, we did grouping. We specifically learned the grouping method when there was how many terms? 4 terms. Number 3, we learned box 1. Again, box 1, the title box 1 is Mrs. Silva made up. So you're not going to find, you don't try to search box 1. You won't find anything, although maybe I should put it out there. It's just a simple way to help you to think of a certain process when we talk about box 1. How many terms do we have? 3 terms. And it's when you have something of this nature. And this is what? A 1. Box 1. There is a 1. The next thing we talked about is box 2, which is again also 3 terms, but the difference is this is not 1. This is any other number. Okay, and then that involves using a box, but also then what do? You would do grouping. So it's a little bit longer process, whereas this one, when you do the box, you just have the answer. This one, you use the box, but then you have to substitute and do your grouping. And again, we'll go through all these in the review, but I want to get this up to refer to throughout. The 5th one we talked about was a difference of squares. How many terms was that? Good, I hope you said 2. Other than GCF, it's the only one that you can try for 2 terms. So you should always try GCF first on everything, then see what you have left. So if you have two terms and you take out a GCF, great. Then come down and see if it's also a difference of squares after you do that. Remember, difference is subtraction. You cannot use it when it's addition. And it's the subtraction between two perfect squares. Remember what our perfect squares are? Any number that is raised to the second power. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, brain fart, 196, 225, missed one. Yeah, there it is. I'm like, I'm missing one. Whoops, I'm off the screen. 169. Trying to move this over and I'm not doing a good job. There we go. Okay. Or it could be any variable raised to an even number. X to the 2, y to the 4, z to the 400th. Doesn't matter. If it's an even power, that's a perfect square. So that's how you know if they're a difference. The last one is the perfect square trinomial. Trinomial. There we go. How many terms? Well, trinomial is, of course, 3 terms. And what's going to happen is when you have the x squared plus bx plus c, this and this are, sorry about this, I'm working upstairs today and I don't have as much room. This and this are perfect squares, and then remember we do this and we multiply the 2. Then we times it by 2 and see if that matches with that. It's the smiley face, is what I call it. And if all those checks, also this has to be a check. Remember there were 4 checks. We check to see if it's a perfect square, check to see if that's a perfect square, check to see if that's addition, and check to see if that will equal to b. If those 4 checks are in place, you have a perfect square trinomial. And whatever sign is right here, that is the sign that will go in your perfect square trinomial. And it'll be of the nature of something minus something times the exact same thing. Let's just say this would be if this was minus, and it's a plus, so I'm going to actually make these a plus. But they're the same. So you can also write it, for example, like this. Whereas up here, it's going to be written x minus a and x plus a. Whatever a is. A is just a number. I'm just using the variable here. So one's positive, one's minus. Down here, they're either both positive or they're both minus. And that is a perfect square trinomial. So there we go. So I'll keep pulling this out throughout the thing, hopefully in such a manner that you can actually see it, because I was having a little trouble there, as we go through this. What I would also recommend is actually when you're doing your review, try to think about or write on your review, like if, for an example, if you haven't done the other review yet, when you do it, write what method you're using. It'll just help your brain to cement a little more clearly what is happening. All right, let's get going now. All right, I gotta find my extra credit. There we go. Okay, prime, get on the calculator. Prime factorization. When you're doing prime factorization, just see the word prime. Prime is a number that can only be divisible by 1 and itself. 7 is prime. 13 is prime. The only even number that's a prime is what? 2. 1 and 2. 1 is not a prime, it's nothing, because you have to have 2 factors to be a prime. 1 and itself, so 2 different factors. So the first one is the number 2. So we learned the ladder with this. So we just set this up, and the key with this was to make sure that what you take out is a prime number. Don't say 4. That's not prime. So we got to start with a prime, and it's always easiest if you see 2's, it's the even number, just keep going with the 2's until you can't anymore. So 2 goes into 120 60 times. Then you repeat. 2 goes into there 30, and I'm just going to follow that 2 train all the way down till I get here. Now it's not even anymore. Doesn't mean we're done, it's just not even. So when I look at 15, I'm like, oh, I could do either 3 or 5. And it doesn't matter because the order of this doesn't matter. You keep going until you end up with the 1 at the bottom. And everything right here is your answer. So 2 to the 3rd times 3 times 5. Do you see that anywhere in here? There it is. Now, keep in mind, there's only like 2 extra multiple choice on the test, so don't rely on multiple choice. But why would this one, I mean, you can tell which one is not the prime factorization without even doing that in this case. On the test, you're not given this. You have to do this. So I understand that you could have looked at this and thought, 15 is not a prime. It's not going to be this one. 8 is not a prime. It's not going to be this one. And 10 and 12 are both not primes. It's not going to be this one. So the only one here that has all prime numbers is this one to begin with. So, you know, be aware of that. That's how you can also make sure you're done. Look at your final answer and make sure every number in there is a prime. All right, so when we go to GCF and I give you 2 numbers, we can still do that awesome ladder method, but we're just going to put them next to each other. And now notice it doesn't say prime, right? The word prime is in here. The word prime is up here. So I can pick out any amount now. So you kind of want to pick out a number that you see as big. So I see 7 right away. Maybe you saw 2. That's fine. You can do 2. But I saw the 7, so I want to do that first. And I see that that divided out is 6 and that divided out is 10. So I evaluate again and I keep going until I can't take something out of both. I see they're both even. I'm going to do it 2. And then that's 3 and 5. And I cannot do any more. Okay, my answer is over here when you multiply them. 7 times 2, my GCF is 14. Okay, so the most important thing here too, well, not the most important thing, but one thing is to know where your answers are in here. Like some of you are able to flow through, but then you get stuck or you leave the 5 down here and you forget it's part of the answer. Know where the answers are. Because you can also find least common multiple by multiplying this times this or this times this. I mean, we can, that's why these ladders are so cool, because you can find so many different things within them. Let's do this again. Now, be careful because some of you might have looked at these 2 numbers and you know off the top of your head 7, but if you didn't work it through, you might have missed that it was 14 because that's not as obvious. So make sure you're really careful not to just go with what your gut is right away. Okay, so when we go to this one, I have 30x squared and 45x squared. So I am looking for the GCF. I'm just going to start actually without my x's in there. I wish I wouldn't have written those. Get my handy dandy white out. And let's go. Because some of you might have saw 5 and maybe you saw 15. But in case you hadn't, this will lead you to going, oh, wait a minute, there's more. 3. It's 15 is my GCF. So that'll prevent you from making the mistake of 5, because again, I don't think it's multiple choice when you're doing it. So you just need to know it's 15. But then you also have to look at the variable. I've got an x squared and an x to the 5th. So you should be taking out whatever they both have. You can't take out x to the 5th. This doesn't have 5 x's. The most they both can give to the cause is 2 x's. So that is your answer. C. All right, when we go down to these ones in the bottom, you know, I know you guys love word problems. I get it. But just like slow your brain down a little bit and try to see what's happening. Mrs. Mendoza is organizing seating for standardized test. 45 ninth grade students and 120 10th grade students will take the test. Each row will have the same number of students. but 9th and 10th graders will not be seated in the same row. So if she puts the greatest number of possible students in each row, how many rows will there be? So since they're not mixing these up, so you can't just add them up and divide to find out how many, you want to find out between these two numbers, what's the greatest common factor between them? So I'm going to set up a ladder between those two. And I see for sure a 5 can come out. 5 goes into that, 2, and E4. Are we done? Nope. I for sure can take a 3 out and get 3 and 8. So that means my GCF is over here, right? But what that means is I can get an even number of rows at 15 students. If I split the 9th grade up by 15, how many rows will I get? 3. If I split the 128 10th graders up by 15s, what will I get? 8. In the long haul, how many total rows will there be? Because that's what the question asks. How many total rows will there be? 3 plus the 8, 11 rows. Okay, there'll be 3 rows of the 9th graders and 8 rows of the 10th graders. But they'll all have the same number in the row, which will be 15. Okay. Okay, so we're getting to factoring now. And I'm going to find my paper. So when you start factoring, and yes, you know, I'm going to say, yep, there's one that you can't factor. And then you write can't factor. But you can't say you can't factor till you try all the methods. Right? It'll be a mistake. And what's the first method I always say to try? GCF. Number 1 every time. Try it. So let's look in here. Can we use GCF in here? Yes, we can, but I don't. I'm sick of that color now, so let me pick a new one. So I'm going to write GCF because that's the method I'm using. And I'm saying there's 2 terms, and we're looking to see what is the GCF, just like we did right here. What is the GCF? What can I take out of them both? Here it was 15x squared. Up here, it looks like I can take for sure a 10 out. If you're not sure, then you're going over here, and you're taking your 10 out, and you're getting that, and you're saying, yep, I can't do any more. 10 was right. So I'm going to take out a 10, and now I'm going to look at the variable. I got a y to the 3rd and a y. What's the least amount? Or what's the, well, least. It's the lowest between the two, but it's the most that they can each give. So the most they can each give is 1y. That's all that one has to give. We open our parenthesis up, and we have the same number of terms in there. So now I got to see what's left. So 30 divided by 10 is 3. Y to the 3rd divided by y is y to the 2. 50 divided by 10 is 5, and y divided by y is 1. So I don't have to put that in there anymore. I lost the y's out front. I took it out front. Another way to think of it is, okay, I had 3 y's. I took 1 out front. How many are left inside? 2. I had 1 y. I took it out front. How many are left inside? None. Okay, so you did that, but the question I've always said is make sure. How many terms are inside? 2. So I'm going to look back at here, and I'm going to remember, okay, the other one that had 2 terms was right here. So I better just check and make sure it's not a difference of squares. And immediately I see the 3, and I know that is not a perfect square, so I am done. So the process here really has to be thorough or things get missed. This is why this is algebra in a high school level class, because it's higher level learning. You're jumping into the analyzing. Let's look at this. All right, so we got these double parentheses in here. And so we kind of have like 2 big terms. We got that, and we have that. When you look at this, what does that make you think of? Do you see a GCF? the thing that you're supposed to be checking. Is there a GCF in both? Yes, there is. They both have an n minus 3. It's the second half of the grouping. So when we talk about grouping, which we're going to do in the next problem, how it starts with the 4 terms, we get to this point in grouping eventually. And when we get to this point, it's really GCF. There's an n minus 3 in both terms, so I'm going to take the n minus 3 out front, and I'm going to open up my parenthesis and put what's left. So if I divided the n minus 3 out of both, we look to see, okay, what's left? And it is an n plus 8. Again, don't just be automatic and done. Look inside. Is there anything I could take out of both of these? No. Is there anything I could factor out of these? No. Now I can say I'm done. Always do that double check at the end. So now I specifically said do this by grouping. So grouping, again, was the only one on here that had 4 terms, unless you had a GCF. But we should check GCF. Let's check before we start grouping. When I look at the 4 terms, is there anything I could take out of all 4? No. There's an A I could take out of 3, and a 2 I could take out of this, and a 5 out of these, but nothing out of all 4. So I'm going to go into grouping. I'm going to put this in here, and if there is a subtraction class right here, remember, shove the subtraction with the 2 and put a different plus in the middle. You want a plus in the middle. And then if there was a subtraction, it'd be inside with the 2. Great. So now I have a 2 parentheses. So now I'm going to look individually and do GCF on this one and GCF on this one. So let's look at this. What's the greatest common factor in there? It is an a to the second. What's left inside? If I divide a to the second out, or I took 2 out, how many are left? 1. If I took 2 out, how many are left? None, except for the 5. And if I happen to not have that 5, I would have put a 1 here. Something has to be there. You can't just let it fall away to the wayside. If the whole thing came out front, it would be a 1. All right, now this goes back down, your plus. Don't forget that. And I look again, any GCF here? And the answer is yes. In this case, there's just a number, whereas here it was just a variable. In this one, there's just a number. Divide 2 out, and we get a minus 5. Now, as you notice, we are right where we were at the beginning of this problem up here, aren't we? What's inside our parentheses? We have 2 bigger terms, and what's inside of both is the same. So let's factor that out, take it out front, open up a new parenthesis, and when I divide that a minus 5 out, it disappears, and I'm left with a squared plus 2 on the inside. All right, keep going. Now it says factoring trinomials. So again, our trinomial ones, where are the ones that are trinomials? Box 1 is a trinomial, box 2 is a trinomial, number 6 is a trinomial, or it could be this one, right? Because GCF could be anything, any number of terms. So, as I've always said, check GCF first. No, there's nothing you can take out of all 3. So, which method? I mean, if we can notice it's a perfect square trinomial, it's kind of fast, but right away I can see that the 21 isn't a perfect square. So, it's not going to be number 6. So, it's going to be number 3 or 4. And 3 is box 1, because this first term, right here, what's before the x squared? A 1. Use box 1 when the number before the x squared, or whatever it is, x squared, y squared, a squared, I mean n squared, whatever the variable is irrelevant. I'm just using x. All right, time for color change. So So box 1 is our all-time favorite because we just set up our little box. And we say what plus what equals the middle number, 10, and multiplies to give you 21. So we have our little puzzle to solve, and then we'll have our answer. And you may see it right away, but what did I say to do if we don't see it? Take the bottom number and do the factors. You have 1 and 21, 2, no, 3 and 7, 4, no, 5, no, 6, no, and I'm back up to 7, so I'm done. Those are my only factors. Those are my only choices. You can see it's 3 and 7. Put them in, because when you get to plus or minuses, sometimes people don't get the negatives in the wrong spot because they don't double check up here. So make sure you double check. And now I'm done with those numbers. I don't need those anymore. These are the numbers I needed, and I can substitute them into my 2 parentheses. It's going to be x plus 3 and 7. Okay, next one. So this was box 1. So let's keep labeling our items here. Okay, number 9. It's a trinomial. Again, we're going to always check GCF first. So let's analyze. Nope, there's nothing that we can take out. The number before the x squared is a 1. So that means it's box 1. So what plus what equals a negative 3? And what times what equals a negative 10? Put your little box around this. And again, if you're stuck, you do your factors. Start with 1. 1 and 10. 2 and 5, 3, no, 4, no, and here I'm back up to 5. So there's only 2 factors to use here, and the one that you're going to add or subtract and get this number is this one. So I know it's going to be 2 and 5. I got to figure out the signs yet, because one of them has to be negative for this to be negative, and I got to end up with a negative 3 up here. So which one would be the negative? Right, the 5. Good. Done with this. I've got my answers, positive 2 and negative 5. Pop them in. X plus 2 and x minus 5. All right, next one. I go to it. I say, all right, is there a GCF here? Nope. Number before the x squared is a 1. All right, box 1 again. Let's solve that. That looks a little tricky, but let's see. Here's my multiples, so I'm going to do my factors. 1 and 55. 2 and nothing. 3. Is that divisible by 3? 5 plus 5 is 10. Nope. 4. 4 go into that. Nope. 5. Yep, 5 will work. 5 and 11. How about 6? No, 6 only works if 2 and 3 worked. 7, no. 8, no. 9, no. 10, no. And we're back to 11, so we're done. Only 2 factors to use here. Now, which one would give you which one when you add or subtract gives you the 16? That one, right? So that one's not going to work at all. So let's put the 5 and 11 in. So I know it would have to be that one, and we got to have one of them be negative. Uh-oh, how's that going to work? Because this one needs both of them to be positive to get that. And this one needs one of them to be negative. I've got a contradiction here. There's no way I can have one of these be negative and still have this work out. Even if I went like that, now I got a negative 6. And if I did the other one, I got positive 6. It's impossible. So I've tried all the solutions here. None of them will work. Can't factor. So I'm not just randomly guessing about can't factor. I literally went through the process. I tried the things. It can't be this, because the difference between this and this, or the addition, would be 54 and 56. So that's not going to work. It has to be these. And every option I tried won't work. So we're done. All right. see here. Just gotta see something. All right. Let's look at this top one. I'm just getting organized, sorry. Do you guys need a break? If you need a break, pause it and go get a drink of water or go do a few jumping jacks or something. Okay? Or take a drink of Zevia. Good stuff. All right. Find an integer value of b that makes x squared plus bx minus 5 factorable, and then factor it. Okay. Well, that means there's multiple different answers here. So which box would we use for this one? Box 1, right? So I'm going to put box 1. And I'm going to set this up just like I would. This number would be what? B. That's what they're asking you. And this one would be the negative 15. So you can start this with all the possibilities that I gave you. So if you look at this, what are the possibilities of things that would equal negative 15? Well, what are the factors of 1 and 15? 1 and 15. Does 2 work? No. 3 and 5. 4 and nothing. So I have two sets of factors that I could put in here. Okay, so you want to put them in here and then see what you would get for this. So for example, if I put 115 in here, but it does have to be a negative. So let's just say, in fact, I need the erasable one for this, because I'm going to have to keep erasing. But you don't have to do all these, by the way. I'm going to show you the different options, but you only have to do one. It just says find an integer value b. And guess what? There's like, let me look, four different answers for b that you could have. So let's do the first one. If this was negative, that would be a negative 1. Or a negative 15, but let's just start with that. So if I go up here and put a negative 1 and a 15, what's b? 14. And then it says, then factor it. Okay, what are my numbers? X minus 1 and x plus 15. You're done with the problem. But just to show you, because you might have had something different, you could have had, instead of putting the negative on the 1, maybe you put the negative on the 15. So you would have a 1 and a negative 15. Now what's b? Negative 14. And what would your answers have been? X plus 1 or x minus 15. That's another possibility for an answer. Again, excuse me, only need one of them. Now, I've exhausted this. I have to actually get the white off for this bottom one. But you could also have done, just to hit everybody's, because maybe you did 3 and 5. Okay, well, 3 and 5. If I did the 3 negative, I just pop it in up there, and I'll see what did I get for b. Negative 3 plus 5 is 2. So I could have gotten 2. What would my answer be? X minus 3, x plus 5. Okay, what if I, instead of doing the negative on the 3, I did the negative on the 5. Now what's my b? Negative 2. What's my solutions? Or what are my factors, not solutions? X plus 3 and x minus 5. Okay, so 1, 2, 3, 4 different possible right answers for that. You just needed one of them. So again, just set it up like normal. Find one that works for the bottom, put it in the top, and write your answer. That's it. Find one that works for the bottom, put it in the top, and find out what this is. Then write your solution using your answers. Okay. Let's see, you're treating your family to dinner at Green Mill. boy, this is random. I think in a different class I did this with something else. I think we had done an activity prior, but that's okay. This is good practice. The bill was $44.39 before taxes. What would you leave for a 20% tip? So, and it says no calculator because I want you to be able to go out with your family and figure out tips without having to worry about grabbing your phone or your or anything. If you look at this, what is that? It's about what? It's about $44, right? Okay. If you slide the decimal over one spot to the left, you have 10%. So what is that if you slide the decimal one spot to the left? $4.40. I'm going to show you this on paper. That's 10%. You won 20, double it. What is it? $8.80. What do you think you're going to leave for tip? Do you think you're going to leave $8.80? Well, if you have cash, probably not. If you're leaving it on a credit card, maybe. Probably just leave $9. Maybe even 10. Maybe you have a 10 spot and you throw a 10 down. Okay, but being able to look at something and just slide your decimal over one spot and go, okay, that's $4.40, double it. It's that easy. That's all you're doing. All right, factor, more factoring. Okay, we look at that. Back to this process. What do we do first? GCF. You know what, before we get into this, let me just pause for a moment and read my words of wisdom for today. The church reminds us of the urgency of being present in the middle of the world so as to guide all human realities back to God. That's why we have to be present in the middle of the world, so when anybody around you is struggling, we can always try to direct things back to God. God is sovereign. He is good all the time, even when things aren't always working out the way we want. All right. Thank you for that little side note. Take a deep breath. Do a stretch. I don't want to lose you guys, so if you need to take a break, go take a break. Come back to it later. Okay? It's better. It's not worth it to have you not engaged. All right. So, GCF. Again, we're checking. Can we take anything out of all three of these? No, we cannot. All right. It's a trinomial. So those are those highlighted ones. Is it a perfect square trinomial? No, because I got a 3 there. Okay, so it's box 1 or 2. Let's see, what's before it? It's a 3. That's not a 1. So it's not box 1. Box 2. So let's try box 2. What plus what equals? What times what equals? So it's similar. It's not the same as box 1. It's similar. Similar in the fact that the first number is exactly, we get the exact same way we do on box 1. It's 47. But it is different in the way that we get the second number. Whereas this used to be a 1, it was irrelevant, but now that it's a 3, we are actually multiplying the 3 times the 140, and that is 420. Wow, we got to figure this out. This is tough. This is going to be a tough one. This might be one of the toughest ones on the sheet. We've got to find all these factors. Holy cow, it's a good thing you can use your calculator. It can help you. 1 and 420. I'm just going to keep working. 2 and 210. 3, does 3 work? Yeah, it should, because when I add it up, I get 6. So 3 goes into there. 140, I think. Wait. I didn't have it on my original one. Yeah, 140. 4, does 4 go into there? Yes. 4 goes in there. 105. 5 goes in there. Oh my goodness. 5 goes into 420 how many times? 84. 6. Well, 6 will go in there. If 2 and 3 did, then 6 is gonna. So 6 does go into there. 70, I believe. And how about 7? Does 7 go into there? Yes, 7 goes into there 60 times. 8. Does 8 go into there? Let's try it. 420. I don't think so, though. No. How about 9? 9 will go in there if you can add these up and get 9, and you can't. So it's not 9. 10 will go in there. 10 and 42. 11. Will 11 go in there? I don't think so. No? How about 12? Let's try 12. 35. Okay, and I guess we can keep going for sure. But before we keep going, I want to just make sure we haven't somehow gotten our answer, because this is quite a list. And since they're both plus signs, we should be able to kind of just look through and see, is there any that add up to 47? 421, 212, 143, 109, 89, 76, 67. We're getting closer. We're going down. 52. Ding, 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 ding. 47. There we go. We got it. You don't have to keep going. It's a lot of factors. You had to have some fortitude on that problem, didn't you, class? You had to practice the virtue of fortitude. Done with those. But now here's the difference with box 2. We're not just done. We don't get just to write x plus 12 and x plus 35. We have to set it up for grouping. So this one's the same, 3x squared. And then we let's try that again. We rewrite this using these two. So instead of writing plus 47x, and I'm going to make sure I add an x to these, I'm going to go plus 12x plus 35x plus 140. And don't forget the x's. It's going to screw everything up, because you're going to get the numbers and then all of a sudden you're like, what's going on? And it's a train wreck. So make sure you don't do that. Now we have 4 terms. So we are using our grouping. Okay, so box 2 leads you to grouping. So I put my parentheses under the first 2, and remember, if there's a subtraction, I would have shoved it over, but there's not. So I now do GCF. See how these all interplay? What can I factor out of both of these? Number-wise, I can take a 3 out. Variable-wise, I can take an x out. So I have x left plus 4. I can take out a 7 for sure. Is that the biggest thing I can take out, though? That's the question. Let me see if 140 is divisible by 35 randomly. It is. Okay, cool. So 35 can be divided out of both. Now you may have only done the 7. And if you did the 7, I just want to show you. I'm using erasable things so that I can do it. If you would have taken only a 7 out, you would have had 5x plus 20. And then you would have said, oh shoot, I can take out another 5 out. And that's where you'd get the 35. Okay? So you wouldn't be wrong. You just, again, you got to have that fortitude and just keep going. X plus 4. Yay! Look at this. I've got my 2 big terms, and I can now take out the x plus 4 out front, factor it out, and when I divide that out, it becomes 1, and I'm left with (3x plus 35). But before I say I'm done, I'm just going to make sure, because it looks pretty done, but then I see these numbers and I'm like, okay, just got to make sure. Can you divide 3 out of both? Because then I should take that out front here. And the answer is no, you can't. But you should always check. Done. All right, let's do the next one. And again, it is a trinomial. There's 3 terms here. That is a plus. So I'm going to try the GCF again. So I'm going to look and analyze these 3. Well, the only one that I can divide that by is 5, so that is not divisible by 5, nor is that. So I am not seeing any GCFs. I do see a trinomial with an a squared, an a, and a number. So since this number is not 1, it is box 2 again, different color time. And I'm going to set it up here so I have enough room. What plus what equals 42, and what times what equals, and remember this is the part that's different. I have to multiply those two numbers, and 27 times 5 is 135, and it's negative. So make sure you don't lose your negative. Sometimes it's almost better, honestly, when things get jammed in there and I'm likely to lose that negative, I'll just darken it so I don't make a mistake. Okay, so here we go. We got to come up with our factors again. 135, another challenging one. So 1 and 135, we always can start with that. It's not even, so it's not 2. Is it 3? Yeah, 3 will work, because when I add these up, I get 9. So 3 and what? 135 divided by 3, 45. Okay. Does 135 work? No. Oh, look at, can we add or subtract these and get 42? Yes. Okay, so I can stop. I'm going to put the 45 in here. I'm going to grab my other pen here because I want to figure out where my negative goes. I have to have this be positive. So where's my negative going to go? That is not that dark. I don't know what the heck I'm doing here. There we go. -3. Double check. Does that work? Yes. Yes. All right. But it's box 2. I have to remind myself. Box 2. And what comes next with box 2? Grouping. So I got to get my 4 terms. So I rewrite the first term. Oh, and I didn't even say that up here. When I grouped this and rewrote this, my 140 there is the same as well. So I rewrite the first term, rewrite the last term, but this middle term gets rewritten with these two numbers, -3 and 45. And I had told you in class that you can do it either way when you write them down, but it's easier if you put the negative first. So I'm going to do that. -3a plus 45a. Don't forget the a. Next we need to do our grouping. If there was a subtraction, and that would be if you put the -3 here, you shoved it with this one and put a plus in between. I have 2 terms. Now I'm doing GCF on each of these. And I see that there's a 3 and an a. So what do I have left? I have a 9a minus, and I took the whole 3a out front, so I put a 1 in there. I don't let it just disappear. I look at this, and I see that there is a 45a minus 5. Yay, I can take out the number 5. Put my plus back in there, and 5, and I get 9a. I took the 5 out, still minus, but it's a 1. Fantastic. I have a 9a minus 1 in both. I'm going to bring that out front. When I divide that out, I get 1. And what do I have left? 3a plus 5. Before I wrap it up, I analyze both of these and I say, is there anything else I could have done? No, there's no more GCFs. There's no difference of squares. When there's only 2 terms left, that's the only thing you can be checking for, right? Is there a GCF or is there a difference of squares? So, and although this is a difference, and that is a perfect square, and so is the 9 actually, but the a is not. If this would have been a to the 2nd, yeah, you could have broke that down. Okay. So then we move on. It says determine whether each value of c makes 5x squared minus 22x plus c factorable. If so, factor it. Okay, so I'm going to set up which box? Box 2. Okay, you're right. Just trying to pick a pen color here. I'll go with purple. So I'm going to set up box 2 because of this number 5 in the front. what plus what equals negative 22? What times what equals? So I guess I have to, oh yeah, I have to do this for each one. Wow, that's going to be a little tedious. But that's okay, because we have fortitude. Okay, so we can do box 2 here, and we can do box 2 here. We can do box 2 here, because we love box 2. We're going to set up our boxes. What plus what equals negative 22? Are you wondering why I'm doing 3 of them? It's because they gave me 3 options. They said, what if C is negative 15? Actually, I'll use a different one. Right here. What if C is negative 15? What if C is 4? Oh, wait a minute. Halt! That is incorrect. I'm jumping the gun here. Back it up. All right. Getting a little ahead of myself here. If C is negative 15, let's rewrite the equation. 5x squared minus 22x minus 15. That would be that one. I'm going to rewrite them all right now. 5x squared minus 22x plus 4. 5x squared minus 22x plus 8. What was I forgetting? Yeah, if it's box 2, I don't just throw the negative 15 and I'm multiplying these. So we have 5 times the 15, which is a negative 75. And then this one I'd multiply. I'm just do them all right away so I don't get them mixed up later or forget. That's a positive 20. Multiply those and I get a positive 40. Why is that in there anyway? I don't know why I wrote that in the first place. Okay, so that's 40. All right, so we have to do all those and figure it out. Okay, so I'm going to try, because I can look ahead and see what doesn't work, I'm going to do that one first. Let's look at this one. 20, 1 and 20, 2 and 10, 4 and 5, and that's it. So I need these both to be positive or negative. And in order for that to be negative, they're both going to have to be negative. So can you see any of these that when I add them together, I'm going to get negative 22? Negative 4 plus negative 5? No. Negative 2 plus negative 10? I'm checking this one. No. Negative 4 plus negative 1 plus negative 20? No. None of these options would work. So that's a big no. Let's see, I think the other ones actually work out, so let's check them out. 1 and 75, 2, no, 1 and 75, where am I? 3 and 25. Well, does 3 and 25 work? Because that's the one that's striking me right now because I'm seeing the negative 22. Yes, 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 we got it. 3 and negative 25, 3 and negative 25. Does that work? Double check. Yes. Okay, I need more space. So I gotta go zoom over here. Okay, because I need to rewrite this, 5x squared. I'm gonna put those two numbers in there. Put the negative first, minus 25x plus 3x minus 15. I'm just going to go through this a little faster, but it's the whole grouping thing again. I can take out a 5x, x minus 5. I can take out a 3, x minus 5. Yay, they're the same. I can take that x minus 3 out front, open up a new parenthesis. When I divide the x minus 5 out, it is 1, and I am left with 5x plus 3 on the inside. So I would go over here. This was the 4, and this was not factorable, because we decided that right here. And when we had negative 50 in the first one, it said if so factor it, so this is my answer. So I have that one. Now I can write that down. And now I got to do this one. So 40. 1 and 40. And I'm keeping this in mind, 2 and 20. And right away I'm wondering, is that the answer? Because in order to be positive, these either have to be both negative. Yep, that's going to work. So negative 2 and negative 20. Does that work? Yes? Yes. Great. All right, so here we go. Rewrite this. But instead of this middle term, I'm rewriting it with these. And they're both negative. So this is good because you can see what happens now when they're negative. Plus 8. So remember I said to jam the negative with the 20. So I'm going to first put the parenthesis around here. But now I'm going to jam that negative with the 20 and make this a positive. So I have a positive on the inside. And the 20 gets pushed inside the parenthesis. So I can take out of this an x, and I'm left with a 5x minus 2. And here I can take out a, you want to always get rid of the negative. So a negative 4, and I get a 5x minus 2. Yay, there's a 5x minus 2 in both. So I can factor the 5x2 out front. When I divide it out, I get 1. And what I'm left with is x plus a negative 4, or x minus 4. Be careful right here too, because when you took a negative 4 out of here, that's how I was left with the negative 2. So go back over here, 5x minus 2 and x minus 4. Woofta! This is getting long, isn't it? Are we almost done, or do we have another? Oh my goodness, we got another whole page. Okay, let's just keep moving. Take a break if you need to. Determine whether, I think the review is a little easier than this, but I could be wrong. I can't remember, honestly. Determine whether the trinomial is a perfect square. If so, factor it. If not, explain why. So again, let's go back to the perfect square. It's down here. Perfect square trinomial. 3 terms. There were 4 checks. Boom, 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 and boom. So let's check. If those 4 fall in place, it is, and then we have to factor it. So is that a perfect square? Yes, it's n. Is that a perfect square? Yes, it's 5. So far, 2 of the checks have come in place. Is this a plus? Yes. Does my smiley work? Let's try it. 5 times n is 5n. Times 2 is 10n. Does my last check fall in place? No. It is not factorable. You can just say the middle term doesn't work, because it says explain why. Other options would have been, if this wasn't a perfect square, you would have said first term isn't a perfect square, or second term, last term isn't a perfect square, or the last sign isn't positive. So, you know, you had used one of those. Now, sorry, I'm just watching my son come home. He took my car and got it cleaned, and then my daughter's fiance came over, but he parked his car where he normally doesn't park it, so I'm like, oh, please don't back up and smash into his car. But thankfully he is a good driver and did not do that. So all is well here in the Silva house. Okay. When we look at this, we have to determine the 4 checks. Let's go. Is that a perfect square? Yes. Is that a perfect square? Yes. Is this sign correct? Yes. Let's do the smiley. 9x, I multiplied them, and now I times it by 2, and it's 18x, and that's the part I check. Is that the same? Yes, this is a perfect square. And now it says, if so, factor it. If not, explain why. So we explained why, but now I have to factor it. So remember, this sign determines this sign. So it's x minus 9 times x minus 9. Or if you want to rewrite it as that, that's fine as well. Same thing. Okay, so they checked the perfect square. Now they're saying, okay, check and tell me if this binomial is, hang on a second. Hello? You know what, I'm recording, so I can't. Call Mary. Bye. Sorry about that. Anywho, is that a difference of two squares? Back to this. Difference of two squares. It's two terms. It has to be a subtraction. And these have to be perfect squares, the two terms. So let's look. Is that a perfect square? Yeah, it's P. Is it a difference? It sure is. Is that a perfect square? Second term is not a perfect square. Okay, because square root of 30, you see that? I don't know if you can see that or not. There, I think you can see it better there. If I put in 30 and do square root, see, it's not perfect. It doesn't come out. If I do 36 and do square root, yay, it comes out perfect to a whole number. Okay, how about this one? 3 checks for this. Perfect square, yep. Perfect square, yep. Square root of 100 is what? 10. Is it subtraction? Yep, it is. So this is the difference of squares. Now, how do you write it? That's the question. When it was a perfect square trinomial, they had the same sign. If it was a negative, they both were negative. If that was a positive, they both were positive. When it is a difference of squares, it is one of each. So I still have 2 parentheses. But one is going to, and these are my numbers. I'm not using these. I'm using these. But it's x plus 10, x minus 10. Or you could have, of course, written it in this order. That's irrelevant. Since it's multiplying, it doesn't matter. Okay. All right, class, we're getting there. We're getting there. Just a couple more. The area of a square is represented by this. Oh, okay, so we're talking about a square. You know, all the sides are the same on a square. Which expression represents the perimeter? Okay, so if this is the area, okay, this thing represents the area. In order for me to get the perimeter, I need to know what a side is. If I know one side, I can just multiply it by 4 to get the perimeter. Well, you know what would be really nice is, because if it's a square, it should be a perfect square trinomial. So it should work out that it's the perfect thing where each side is the same, whether it's plus or minus, I don't know, but they should be the exact same thing. So let's take a look at that. That's pretty groovy. All right, is this a perfect square? Yes. Is this a perfect square? Yes. Is this a positive or plus? Yes. Smiley face. 5z times 2 is 10z. Does that match? Yes. Yay, it's a perfect square trinomial. What's the sign? Right here. Plus. Z plus 5 times z plus 5. Perfect. That's the sides. Because you know, area of a square is side times side. So each of my sides are z plus 5. So to get the perimeter, you can add those all up. 1, 2, 3, 4, z plus 5, 10, 15, 20. Or you could have just taken one of them and multiplied it by 5z and got 4z plus 20. Oh my goodness, now who's here? Honestly, I'm looking at like 5 cars in my driveway. Okay. All right there, buddy. What's going on at the Silva house now? All right. Anywho, so that's 4z plus 20. Yay. There's my answer. Again, don't expect a lot of extra credits. Now, these questions can be a little tricky. Tell whether this is completely factored. Okay, so it's somewhat factored, right? I mean, we have two parentheses. But you have to look inside each parenthesis. And since I look in here and I see two terms, and I look in here and see two terms, the only things I should be checking for at this point, there's no trinomials, is I'm either looking to see if there's a GCF, or I'm looking to see if there's a difference of two squares. Those are the only two options I have right now. So when I look in here, is there a GCF? No. Is there something I could factor out of both? No. That's GCF. Sorry, I just repeated myself. I'm too distracted. Is this a difference of squares? Well, it's a difference for sure, but that's not a perfect square, nor is that. So that one's fine. How about this? Is there a GCF here? Yes. What can we take out of both? A 4. And because this is multiplied, I can just put the 4 out front. So I'm just going to rewrite the x minus 5 right there. And if I take the 4 out of this, like I did right here, I'm just putting it in the front instead of putting it in the middle, because that doesn't really look nice mathematically. If I divide that by 4, I'm left with an x. If I divide that by 4, I'm left with a 3. Now, is it done? Is it a difference of squares? No, it's a plus. Okay. Factor each completely. So these are where they get a little tricky. This was like the last section we did where you look at them and it's like, okay, here you go. I'm giving you nothing to go by. But since I've been going through this whole worksheet, I've been trying to guide you on this. What's the first thing you try? GCF. Hands down, immediately. So we look at the GCF and we see we have 3 of them. What can I take out of this? Let's look at the numbers first. I got 4, 30, and 16. Can you take a 4 out of all of them? No, not the 30. So 4 is not going to work. How about 2? Yeah, the 2 will work. Okay, let's look at the x's. If I have x to the 5th, x to the 4th, x to the 3rd, what can I take out of all 3? I can take out the lowest one, which is x to the 3rd. I set up and open up another parenthesis here. And because I took out a positive number, nothing's going to change. So I'm going to have the subtraction here and the subtraction here. But I should still have 3 terms. When I divide 4 divided by 2, I get 2. When I had x to the 5th and I took 3 of them out, how many are left? 2. Let's go to the next one. 30 divided by 2 is 15. X to the 4th, I took out 3. How many are left? 1. 16 divided by 2 is 8. I had x to the 3 and I took them all out front. How many are left? None. So GCF, let's look again. Anything else I missed? Because sometimes we just don't see them all at once. No, there's not any more x's and there's no number. I can take out all 3. So that's done. But it doesn't mean you're done with the problem. You still have a what in there? A trinomial. So I know that I can still try box 1, box 2, or perfect square. So is it perfect square? No, 2 is not a perfect square. So that's out. So it's either box 1. Is it box 1? No, because that's a 2. It could be box 2. So let's try it. So box 2, what plus what equals what times what equals, put my little box. And this, kids, is the same. So this is up front. So you just, you know what I'm going to do? I'm going to highlight it because this is what happens is people forget about it. When I'm done with the problem, that goes in the front. Okay, but right now I'm just focusing only on this. So I look at this and I think, okay, what plus what equals negative 15? And then I got to multiply those two to get negative 16. So let's see what works. 1 and 16. Does that work? Yeah, I think it does. I don't think I have to go any further in my list. 1 and negative 16. Let's double check that. 1 times negative 16 and 1 plus negative. Yeah, ding dong. There we go. So we are going to change this middle one. Again, I'm not worrying about this now. I highlighted it, so I'll get it at the end. Box 2, I go to grouping now. So 2x squared, I rewrite that, and now instead of writing this term, I use these two numbers. Which one should I put first? the negative, minus 16, and don't forget the x, plus the 1x. Rewrite minus 8. All right. Go in here and get a darker one. Put parentheses in here. Now when you look at these, what can I factor out of both? I can factor a 2, factor an x, and I'm going to be left with x minus 8. I look at this. I don't see anything. Does that mean there's nothing there? No, that doesn't mean there's nothing there. What's there? What's right before the parenthesis? What is it, class? What is right before the parenthesis? 1. So I got the x minus 8. I pull that out front. When I divide it out, it becomes 1. And then I have the 2x plus 1. And I look inside and make sure, is there anything else in here? Nope. Anything here? Nope. Oh, good thing I highlighted that, because after all that work, I would have forgot it. That just goes out front. Nice. Hallelujah. We're on the last one. This is the all-time longest video ever. I apologize. Well, actually, I think my geometry was longer. Sorry. I'm going to get that one next year. What do you do first? You should be just having this memorized by now after drilling this here. GCF. Always check GCF. 3m to the 4th and 48. Is 48 divisible by 3? 4 plus 8 is 12? Yes. So when I take a 3 out front, I open up a parenthesis and put what's left. 3 divided by 3 is a 1, so I'm left with just the m to the 4th. And 48 divided by 3 is 16. Okay, great. Now what? Are we done? Close the books? Say goodbye? No, because we did not analyze. Look inside here. Is there any other GCF? Did we miss anything? Nope. There's no number here. There's no m here, so nope, this isn't going to work. Well, I mean, there's a number, but it's a 1. Okay, and there's only 2 terms. So what was the other one we can try for 2 terms? Difference of squares. So number 1, was it a difference? Oh, good, it was. It was a difference. Were they perfect squares? Yeah, that's even. So the square root of that is just divided by 2. Square root of that is 4. Awesome. And what did we do when it was a difference of squares? One was negative subtraction and one was addition. So again, I do not want to forget that 3. And this is again one of those situations where we just forget that guy out front. So I'm going to do m squared plus 4 and m squared minus 4. And I don't want to forget that. So I put it out front. And we analyze again. That's fine. Okay, there's 2 terms. So what should we double check if there's 2 terms? Difference of squares. Has to be subtraction. That's addition. Oh, that's not difference of squares. Okay, so we're done with that one. Any GCF? No. Go to the next one. Any GCF? No. How about difference of 2 squares? Oh. Oh. That is a difference for darn sure. And that is a perfect square. And that is a perfect square. Oh my goodness. It's another perfect square. So now, while I'm doing that, I don't want to miss and forget about this stuff up here. So I'm going to highlight that while I work on these. I'm recording, Mary.
Sound like you're talking to preschoolers.
Oh, okay, thank you. I didn't need that, but anyway. So now I'm going to do m plus 2 and m minus 2. Oh, don't forget your highlights. And voila, check that out. Okay? And honestly, let's just nail this test. And you can just go right out and call yourself Einstein after this, okay? Because that's you who have earned the title after this test. Seriously. You can do it, though. You can do it. Let me think if there was anything else that I wanted to say. Nothing. I think this is long enough. So take care. I'm gonna do the review video. I will try to go through it a little faster than this video, since that's when I took so much detail time. I'll try to go a little faster. But again, do the review first, check it, so you know which problems, and then after you see how I did it, go retry them again before the test. All right, folks, have a great day. Bye-bye.